Alright, this is page 4 of the review worksheet for chapter 13, and in number 41 we're supposed to find the function that has the amplitude of 2 and a period of 4 pi. So amplitude of 2 is going to be one of these two, and the period of 4 pi, if the period is 2 pi over b, and that's 4 pi, then multiplying here I can see that b times 4 pi is equal to 2 pi, and so I can divide out the 4 and the pi, and I get b is 1/2. So if the amplitude is 2, then a is 2, and b is 1/2. So that would be choice A. In number 42, the period of the function, so the period will be 2 pi over b, or 2/3 pi, 2 pi over 3. Number 43, the range of this function. Okay, so this function, d is 0, right? So this is not lifted up or shifted down from the x-axis. This is just at 0, and we go up by 4. So the maximum value will be 4. The minimum value will be -4. So the range of the function is going to be all of the y values between those two. Number 44, the period of the graph of the equation. So b right here is 1/3. So the period is 2 pi over b of 1/3. So this is 2 pi times 3, or 6 pi. In 45, the equation of the graph below. Well, it's starting in the middle. Looks like it has an amplitude of 2. So a will be 2. This looks like it's a sine function. And the period goes all the way and comes back, and it is 2 pi, so b is 1. And it does not appear to be shifted horizontally or vertically, so this would just be choice D. Y equals 2 times the sine of x. Number 46, they want the equation of the graph shown. Well, one of the things is we can see that a is 1 here because my amplitude, I never go above 1 or below -1. But look at it. It looks like I only do half of a cycle, half of a period in 2 pi. So if I come back up and where I'm back to where I started, that is going to be out here at 4 pi. So if the period of 2 pi over b is equal to 4 pi, then b times 4 pi is 2 pi. And again, b is 1/2. And this starts at the top of the function, so that appears to be a cosine. So I get the 1 times the cosine of 1/2 x, which is choice A. Okay, moving on to number 47. This graph, again, does not finish. If I go from here to here, that's only half of a period. So this function's got to continue out here, and it'll get a full period in out here. If this is 2 pi, this will be 4 pi. So just like we did number 46, if the period is 4 pi, then b must be 1/2. And again, the amplitude appears to be 2. We're not lifted off the x-axis at all. I go up to +2 and a minimum at -2. I start in the middle of the function, which tells me a sine function. So this is 2 times the sine of 1/2 x, so that would be choice C. Number 48, I'm supposed to say what's the equation here. So I look at my max at 3, my min at -3. This is in the center, so D is 0. The amplitude is 3. It looks like I come back right to where I started. 1 full period is 2 pi, so B would be 1. And there does not appear to be a phase shift. However, I notice that I start in the middle like sine, but instead of going up and then down and back, I go down. So that would make this amplitude -3, actually. A is -3, the amplitude is 3. So the equation would be y equals -3 times the sine of x, 1x. No phase shift or horizontal shift, but definitely this right here would be the regular sine function, and it's been reflected, and that's what that does. Okay, number 49, between -2 pi and pi, the graph of cosine is symmetric with respect to, well, cosine is the poster child for even functions that have y-axis symmetry. If I look at the parent function, it's perfectly symmetrical like this over the origin right here. And then the last one, number 50, which graph represents the reflection of y equals cosine x in the y-axis? Now, it didn't say over x. It didn't say reflection, because cosine of x looks like this. The reflection of cosine of x, or negative cosine of x, where a is -1, would be, would flip down over the x-axis. But this just looks like, here's cosine of x, and here it is, the other side of it, a reflection in y. I guess that's what this one is asking for. So that would be choice B. So that's it with page 4 of this review worksheet.